We talk about eddy currents in this lecture. So say you have a flat copper or aluminum plate, and this plate is swinging in a magnetic field as shown in the figure. So you have this copper plate and this is swinging in the magnetic field. Now this pendulum will come to rest very fast. So the motion is damped in the magnetic field. Now why does this happen? Now as the plate enters the field, the magnetic flux changes. So when the plate is entering in the field, the magnetic flux changes, and when the plate is leaving the field, the magnetic flux is changing. So this causes current to flow in the field, and this current flows according to the Lenz's law. So this current flow is called eddy currents. Now these currents have been marked in blue here. So this is the current, this is the eddy current. So these eddy currents then produce a force that opposes the motion. So if the velocity is this way, the eddy current will produce a force opposite to the velocity. Similarly here, the velocity is this way, the eddy current will produce a force in the opposite direction. And this is precisely this force which brings the plate to rest. Now these eddy currents are extremely useful, and we will give two examples of eddy currents practical use. The first one is electromagnetic brakes in the trains. So what is done is, powerful electromagnets are attached to the trains and they are placed very close to the steel rails. So when the driver wants to brake, huge amount of current is passed through the electromagnet, and the relative motion of the magnet and the steel rails, this motion, relative motion, produces eddy currents, because the magnets are placed in the train and the magnets are moving with the train, and therefore the steel rails are constant, and this change in flux on the steel rails produces the eddy currents, and the direction of the eddy currents is such that it will slow the train down. Now since eddy currents decrease steadily, the braking action in the trains is very smooth. So second application is induction furnace. A high frequency alternating current is passed through a coil which surrounds the metal which we want to melt. So eddy currents are produced in the metal. So these eddy currents then heat up the metal and cause it to melt.